Thank you all for the presentations. My name is Mahdi Abu Huraira. I'm currently an MSc Ahmed Bello University, Zaria, studying computer science. So the topic for my presentation, I think an introductory phase have already been established by both the keynote speaker and the two presenters.
Good morning, all. Good morning, all.
Hello.
Yeah, we can hear you. You can continue the presentation.
Oh, okay. So as I was mentioning, both the keynote speaker and the two presenters also talk about trustworthy AI, safety, and all those things. So I'm also grounding my research in that aspect. The presentation is titled "Quantifying Robustness in Safety Critical Deep Neural Networks." Essentially, I'm trying to develop a flow such that from training a model to verifying it formally using mathematical tools. So why do we need to do formal verification? Normally, when you train a model, we often go for the statistical test. So you run your test train, compare with train and test data, and then develop some sort of accuracy metric, say 99%, 98%, and all those. But those were statistical tests. With formal verification, we'll have an empirical testing. So we can have actually an input that we will use mathematical formula to determine whether this result that we have from the model satisfy that condition. And in this case, we are targeting robustness, in which we will measure reality gap. And by that, we mean, say a model is trained and has an accuracy of 99%. But when we actually use real values with some perturbation in the input, and we were able to produce only 3 good results out of 5. It means we are only able to verify 60%. The gap there will be the 40% percentage point that differs from the statistical accuracy to the verified value. So in safety critical AI, we are usually treating the worst case scenario, because when we say safety critical areas, we are talking about healthcare, autonomous guidance vehicles, and all those things. So there, we are not only concerned about your 99%, the 1% also matters. So that is why we need the formal verification. How do we intend to do this? So this is the flow of the pipeline. When we first train the model, we'll export it in a standard format that can be used everywhere. So in this case, I choose ONNX. And then we will use we'll specify the property to verify, which in this case is robustness. Here we will define an epsilon board where we will treat all points around that region. And then we will use a hybrid verifier. The hybrid verifier uses first the IBP, which is the interval bound propagation. And then if that fails, we'll try the abstract verification. If that fails, we'll finally result to using Marabou. And then finally, we will decide based on the outcome. So in this experiment, we use the MNIST data set. We break it into different neural nodes. We try with the 96 neural nodes, and then with 448 and with 890. And each case, we record the number of samples we are able to verify mathematically. And the target, we take 3 metrics. So the epsilon, meaning the range at which we will verify the inputs, and then the time we give the experiment to run, and finally we will evaluate whether the Marabou tool is able to find a counter example or not. So these are the findings. We identify that when epsilon is specified at less than 0.003, we were able to verify all the samples we pick, so 100% verified. But when we start increasing the epsilon to around 0.01, we were only able to verify 60% inputs. And at the moment we started reaching 0.05 to 0.1, it's become intractable. So we cannot really verify that, at least with the 300 millisecond we specified. This the second finding is that verification will hit a size limit. So the larger your model, the lower the chance of you having to verify it at least in real time using mathematical tools. So once the size of your network reach at least 896 ReLUs, then it becomes practically impossible to verify in real time, which is a bottleneck currently. And then, so there are models that are specifically trained to actually bypass or at least take into consideration such perturbations. We call them the PGD trained models. So this in this research specifically, we were not able to establish a significant difference. So I trained one model using the PGD and then the other without the PGD adversarial training, but both of them actually have the same accuracy, and in terms of the verification, there is not much noted. And then the last part is the dimensionality. So the Akazu is not as diverse. By dimensionality, we mean the input points we are taking. The Akazu uses 5 input dimension, while the MNIST have like 784 inputs. So the dimension is very high. So when your input model takes a less number of inputs, it becomes easy to verify mathematically, while if you have larger like a large dimension model, then it becomes difficult to verify also using mathematical models. So what are the takeaways from the experiment? In general, if you want a formally certified model, then you should focus on designing a small enough network so that you can have a formal certification. The budget also matters. So the range at which you consider perturbations, which is the epsilon, the timeout you specify for the verification experiment to run, and then also your architecture. So, and then finally, the PGD might help accuracy. So if your focus is on statistical accuracy, you might be able to improve it using the PGD training method. But formally, at least for this paper, it doesn't really show much difference whether you train the model using the adversarial perturbation or not. Thank you all. I kind of speed run through the slides because of the time, but I think all the details can be found in my GitHub here, and then you can contact me via my student email. Thank you.
Thank you very much for the presentation. Now we take some questions. Any question from Mr. Mahdi Abu Huraira? Any question from the audience? Participants? You can unmute and ask the question. Thank you. Seems we have no question. So we will move to the next presenter. Okoyemi is not here. Is he?
Oh, okay, I'm here. This is Abunike Chibike.
Abunike. Okay, let's have you. You have the floor. 10 minutes. Abunike, are you sure you should be here?
Yes, I'm here. Why not?
Engineering.
Sorry. No. This is a theater. I don't even know why I was included here.
Yeah, you should join the other one for your
Which one?
strand. I don't know. Maybe you check the strand.
But I
Which
was included from the mail I
for
got.
engineering and mathematics.
Are you kidding me? So I have to join social science and humanities.
Yes, sure.
Oh, okay. Thank you so much. Thank you.
It seems Abdulatif is not here. Can we have Kabir Suleiman? Kabir Suleiman. Is he here?
He's not here.
Okay. Adeyemi Isaac Temitope, right? Adeyemi is here.
I'm here.
Yes. Okay, let's have your presentation. You have 10 minutes, and there will be question and answer after the 10 minutes. You have the floor. Thank you. You can share your screen. You can share your PowerPoint with us.
All right. You can wish the next thing. I just want to be sure.
You can see.
All right. All right. Good
Thank you.
morning. My name is Adeyemi Isaac, and
Yeah.
I'll be presenting.
Oh, can you be louder than that? We can't hear you.
All right. Okay, what about now? Can you hear me?
You can barely hear you. Not audible.
Okay. What about now? Thank you. Can you hear me now, sir? Can you hear me?
Ash. No. Do you have a microphone? Maybe you can move it closer to your mouth.
Yeah. What about now? Can you?
Now it's better. Yeah,
Okay.
start. Thank you.
Okay. I tried to disconnect from my. So, good morning, and I'm Isaac Adeyemi, and I'll be presenting a research topic that says Beyond Generative AI, examining the mathematical gaps in autonomous and agentic system design. We are in artificial intelligence world, and there are tons of artificial intelligence models being built around now, and there is one thing that is being currently ongoing now, which is the agentic AI, because we have generative AI and we have agentic AI, and but agentic AI is a system that do things with minimal human supervision. And we also have autonomous system. What is autonomous system? Autonomous system is the one that executes decisions and operates within an environment without continuous human intervention. It's not that there will not be human intervention, but minimal human intervention. And some examples of like just one of the examples of the autonomous system is a self-driving car maintaining lane positions, and the AI agents that we are all familiar with are AI agents that browses the web like clouds and the likes. So like we can classify them as one of the agentic AI that we have now. And agentic systems are built on three principal mathematical pillars. We have three pillars that agentic system based on the research. Agentic systems are built on reinforcement learning, which allows agentic system to act, not just to predict, it allows them to act. And we have the stochastic optimization. It is the agentic system. This is the agentic system that um helps the system to know what to do. It converts, okay, this is the system layer that translates what we want the system to do into a single number the system can optimize again. And we have the probabilistic inference. So these are the three key pillars that agency systems are built based in mathematical pillars. So the aims and objectives are clear. We have 4 aims and objectives. The first aim is to formally identify three structural mathematical gaps three structural mathematical gaps. Also, to establish that these gaps are mathematical deficiencies. And the next aims and objective is to propose 3 necessary conditions for sound autonomous system. While the last objective is to provide researchers and system designers a principled evaluation. Sorry for that. All right, please. I just want to be sure. Can we see my screen?
Yes, we can. We can continue.
All right. So the last one is to provide researchers and systems designers a principal evaluation framework, like a framework that can help researchers and system designers to work on to have an effective AI output. So this is not the research is a conceptual analysis. It is not a data connection. Like, we did not collect any data from anywhere. It's just like a proof style argument. And the procedure, we have 4 stages that we use. The 4 stages were formal specification, like where we established theorems in the literature, and it all occurs in both the RL, which is the reinforcement learning, and the stochastic optimization and the probabilistic inference. So, and the mathematical approach is still, for reinforcement learning, the mathematical approach that was applied was Bellman's optimality equations. So, and for stochastic optimization, the mathematical approach that was used was scalar utility theory, while for statistical learning, it was Vanik, Chavonicki's theory that was applied for the mathematical approach. And the key findings are the 3 structural gaps as it has been implied in the aims and objective, that to establish this, to propose to formally establish 3 structural mathematical gaps in this current agentic AI framework. Sorry for that. So the 3 structural form for the framework of the gap, for the framework of the reinforcement learning, the assumption violated is that the convergence guarantees assume environmental stability, while for the scalar was that single scalar insufficient for real-world objective. Statistical learning theories, the generalization bounds, fixed generational bounds presuppose fixed data distributions. And one thing about all these things is that these are not engineering problems. These are not engineering problems. They are mathematical deficiencies. And they are not engineering problems that can be solvable by scale rather. Sorry, what is scale? Scale is just like you making the AI system bigger or training it small. Because some people will be like, okay, once there's issue that they have to train the AI more. So that's just what scale means. And one of the reasons, there are 5 reasons why scale cannot fix this. Number 1 reason is more data does not change the assumption the mathematical rest on. And another one is faster processors do not repair violated convergence guarantees. Larger model do not resolve insufficient reward. And the four point is scale amplifies the consequences of the mathematical deficiency. It does not eliminate them. So you fixing your model or you trying to train it more does not eliminate the deficiencies. It's rather amplifies the consequences of the mathematical deficiencies. Why there is another point is high-stake deployment with minimal human oversight make this a structural risk, not a theoretical concern. Because once the theoretical aspect is affected, the engineering too will also be affected. Yeah, we also be affected. So the proposed framework is the condition 1 is non-stationary validity. System must remain mathematical valid as environment change. So no matter how not just when there is not just under stable conditions, the system must always remain mathematical valid. So another objective is representational adequacy. Why another condition is distribution adaptive optimality. System must maintain performance because it's just like conditions that reproduce. And system failing anyone is mathematically afforded for autonomous deployment. So in short, these conditions help the theoretical parts of the AI, of the agentic AI, to be much more effective. And some of the significance and the contribution is that formal identification of these 3 gaps as mathematical, not engineering deficiencies. So it is not engineering deficiencies, it is the mathematical deficiencies. And these conditions that we propose can actually help us to fix the deficiencies. And also it helps to provide researchers and system designers a principal pre-deployment evaluation framework So, and also it reduces risks associated with mathematically EU-founded agentic.
We can't hear you, Isaac. Isaac, are you with us? I think you've been muted. Isaac,
Oh, sir?
we lost you. At some point, we lost
Okay,
you.
okay. Okay, sorry, please, around way.
The contribution.
Okay, 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 okay. Sorry, I'm trying to.
Maybe you can
Sorry.
conclude
Okay, okay, okay.
your conclusion.
All right. In summary, current agentic AI rests on mathematical foundations, and this with three structural gaps, as I've said earlier. And these gaps cannot be fixed by scale. As I said earlier, that scale is just more or less like you training your model more. So it cannot be fixed by scale. It cannot be fixed by scale. So, and another conclusion, another point is non-stationary validity, objective representation adequacy and distribution adaptive optimality are necessary conditions for safe deployments. These three gaps is just for us to it's just to optimize the mathematical gaps. And researchers and system designers now have a principled framework for the pre-development evaluations to evaluate it before the engineering works and the whole stuff commenced. So thank you so much.
Thank you very much for the beautiful presentation.
Okay.
So the questions can come in now. And please do fill the feedback forms for the presenters. Thank you.
Okay, right.
You may not need to fill for yourself, but you should fill for others.
Okay, 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 okay.
Yes, no need to fill for yourself.
Okay.
Other participants should fill the feedback form. Thank you. Any question? Okay, thank you very much once again. So let's move to the next presenter.
All right.
Is Opeyemi here? Opeyemi Bakari. Kabir Sulaiman. Is he here? Okay. Adegoke. I think Adegoke Hannah. Is she here?
No.
No. Ugochukwu. Are you here? Okay. Yeah, we have Ugochukwu here. Can we have your presentation now? Mr. Ugochukwu or Dr. Ugochukwu? Okay, good. So you have the floor, 10 minutes presentation, and there will be question and answer afterwards. Continue, please. Start. We can't hear you, but we can see your screen. Ugochukwu Daniel. Mr. Daniel, we can't hear you. Hello. You should unmute yourself. We can't hear you. But I think he's presenting already. Hello. You need to unmute yourself for us to hear you. I think we may need to move to the next presenter. Since he can't hear me, I don't know. Diguk is not here.
And high implementation costs could be a limitation.
Dr. Aminu? Dr. Yakub?
Hear you. I can hear you. Sir.
Is that okay?
Yeah, it's okay. Thank you.
Okay. Do we have more questions, contributions, or suggestions? Okay. Thank you for the wonderful presentation. So, seems other presenters are not here yet. Okay. Adeguke. Kabir Suleiman. Okoyemi Abdulatif Bakari. Let me see if I can find him from here. Hello, Hannah. You are assigned here. Can you hear me?
All right.
Yeah. So, can we have your presentation now? Adeguke Hannah, right? Is it?
Yeah. Yes.
Okay. Thank you. Then you can present now.
Can you see my screen?
Yes.
But
But not that
I think
it's too small. Maybe you can enlarge
I
it.
think I sent my presentation earlier.
Okay, let me see if I can find a project for you. I don't have it. How did you send it? Was it through email? Hannah.
Yes, I sent it to you.
Okay, I think I can find it. Bridging the gap. Okay.
Yes,
I'm sharing now. You can start. You have 10 minutes and there will be question and answer afterwards.
Okay. Bridging the gap, implementing use of genetic AI in animal health technology. My name is Abosede Hannah. I'm the graduate of animal health technology from Federal College of Animal Health and Production, Ibadan. Next slide. Next slide, Sean.
Yes,
Hello?
yes. Oh, can you see it?
Yes, I can.
You can see the next slide.
Yes, sir. But
Okay.
let me go to the introduction. Things I only have to
Introduction. Okay, okay. Oh, yes, yes.
So animal health is rapidly evolving advances in artificial intelligence, particularly the shift from generative AI, which supports data analysis and prediction, to generative AI, systems capable of autonomous goal-directed actions. This shift is already visible in tools like OCR Real-Time Pro, which autonomously detects trust and early disease pathway and vet GPT, which generates rapid differential diagnosis from clinical data. This system promises improved diagnostic precision, but raise critical questions around accountability, data integrity, and veterinary roles in decision making. This research, therefore, examines the implementation of the genetic AI in animal technology, arguing that responsible adoption requires a clear ethical governance framework. 1 year autonomous systems remain adoption and licensed veterinarians retain final decision-making authority. Next slide.
Yes.
So AI has already started as a supposed to which we ask questions, it responds to us, that is generative AI. But now we enter into a new phase, which is a generative AI system. So veterinary practices taking going diagnostics complex. So veterinary practice globally is under pressure. Diagnosis cases are becoming more complex. There are fewer practitioners per animal population, and demand for faster, more accurate precision is growing. This is a conceptual research, which means we are not reporting a field experiment. We reviewed existing public literature and evaluated it through veterinary ethics lens, asking as AI become more autonomous, how should veterinary professional respond to this? That's right. Next slide. So veterinary practices faces growing diagnostic complexity. AI has shifted from generative to genetic. System now adds
We can't hear you.
so system now acts independently. This shift is not just technical, it changes the entire.
We can't hear you. We can't hear you.
Hello, sir.
We lost you. We couldn't hear you for some time, for some minutes.
Hello.
Yes, we can hear you now. You can continue. We've not been hearing you for some time.
Hello, can you hear me, sir?
Yes, we can hear you now. Continue, please.
Yeah. Okay, sir. Please let me go back to that statement of the problem.
This one?
Yes. I
Can you
think I
see?
stop at this. Yes, I can. This shift is not just technical, it changes the entire relationship between the veterinarian and the tool. Next slide, sir. So the two machines I'm using as a case study, the SCR X-Time Pro and VetMed GTP. Next slide, sir. So this SCR X-Time Pro is a wearable sensor placed on cat's neck at their neck. It continuously monitors each animal's rumination patterns and movements 24 hours a day without any human instruction. It detects when an animal is coming into distress or showing any signs of disease. So it flags automatically. You don't need to press the button, and this system also decides something was wrong. Something is happening and reported it. Next slide, please. Next slide, sir. So we also have the VetMed GTP. It's a diagnostic imaging system built on VetMed GTP. Hello.
Hi. You mean the next slide? Okay.
So the generative pre-trained transformer developed by Izemi Said and Hussein for veterinary health care. It takes in clinical. Okay, the framework. Number one, the human oversight is non-negotiable. A licensed veterinarian must remain the final decision-making authority for every genetic AI. We can't dispute the fact that human is still be the one to give us the final diagnosis. But this system advises, the professional decides. This is single most important principle in our framework. Like AI recommendation are advisory, not directive. Secondly, clear accountability structure. Institutions deploying this system must define in writing who is responsible when AI assisted decisions lead to poor outcomes. This must be established before deployment, not after something goes wrong. Next slide, sir. Let's nice, sir.
Yes, you have it.
Thirdly, data integrity. The output of this system are only as reliable as the data going in. Practitioners must be trained to evaluate input quality and also to understand the limitation of what algorithm can and cannot see. So this framework is designed to be compatible with international veterinary standards. It does not block the use of a genetic AI. It creates the condition under which that use is professionally and ethically sound. Let me just go to the conclusion since I don't have much time left. So in conclusion, a genetic AI in animal health is not coming. It's already here. X-Time Pro is on farm today. Diagnostic algorithms are being used in clinical settings right now. Our field has a choice. We can engage with these tools critically and shape how they are used, or we can ignore them until they shape us. Lastly, what we are arguing is simple. Embrace the technology, but keep the veterinarian in charge. Not because AI is the enemy of good practice, but because good practice requires human judgment that no algorithm currently replaces. Thank you very much.
Okay. Thank you very much for the presentation. Do we have questions, suggestions, contributions for Ms. Anna? Any questions, suggestions, or contributions? And kindly fill the feedback forms. It's been pasted on the chat.
Hello, Miss Anna, right?
Yes.
Yeah, I have a question regarding I think in the last slide you mentioned maybe accepting this technology. So since you mentioned in the beginning of your presentation that it's like literature review. So how different maybe government agencies or maybe some veterinary maybe professions accepting this technology?
Like I said earlier, some farms are already using this technology, while some veterinarians are against it. But truth be told, if you look at it, I feel that it's still preferable we use it because we are not on the farm 24 hours. But if we have something that can replace us while we are going, I feel we should embrace this too, so that there won't be any, because there are some animals that if a disease is not discovered early, one way or the other, we might lose the animal because we did not discover it because they can't talk. It's only when they show signs and symptoms that we know something is wrong with this animal. But with this AI, a genetic AI now, we'll be able to be proactive and not discover it when the disease already hits the animals. So I feel that if we continue to hammer on it, they will come to a conclusion that a genetic AI is the way to do when it comes to animals and disease prevention and also the historical sites and that. I
All
hope I
right.
answered your question.
Yeah, thank you for your answers. Thank you.
Yeah, thank you for the presentation. Okay, so we can move to the next presenter. So we have just two left. I don't know if they are here yet. Kabir Suleiman, Okoyemi Bakari, Abdelatif. Okoyemi, I think he's not here. Let me see if I can find them from the other rooms. By the way, please help fill the feedback forms. Yeah, this is Kabir. Okay. Mr. Kabir, hello, can you hear me?
Hello, I can hear you.
Yeah, you are assigned here, engineering and mathematics. So can we have your presentation now?
Hello?
Yes, we can hear you. Can
Okay,
you hear me?
okay.
Yeah, let's have your presentation.
Okay.
So we'll have 10 minutes and there will be question and answer afterwards. So you can share your screen and start.
Okay, okay. Let me share my screen. Okay. Okay, please can you see my screen now?
Yes, we can. We can see your screen.
Okay, great. Okay.
Start, please.
Okay. Good morning. It's morning here, so good afternoon over there. My name is Kabir Alamun Suleiman. I am presenting on the development of an intelligent chatbot for university pre-admission course guidance using JAMB IBAS data. So starting with, it's safe to generalize that 99.9% of the audience here, we are Nigerians or we can relate to Nigerian situation. So this is my outline. I'll be very brief and fast about it. So a quick background. So admission in Nigerian institutions, like tertiary institutions, is governed by JAMB, and the course and institutional requirements, they are published through this system they call IBAS, Integrated Brochure and Syllabus System. Just to relate with that, every brochure hard copy that we used to have then, it was digitalized and made available in soft copy. But however, many admission seekers still make the wrong choice of subject combination because they have difficulty in interpreting that subject. They are like looking for their course. That document usually is very bulky. I don't know, probably because of the size, because of the bulkiness, that was why they call it brochure. Just kidding anyway. So because of the students prefer to look for simpler source of information, they go to blogs, and most time they get information that are not up to date, that are not valid. Some even go, because of the age we are now, people go to ChatGPT, type in, I want to study computer science, what are my subjects combination? Of course, just like Dr. Kehinde spoke the other time, generative AI will give you a response. But what is the reliability and how does it match your current scenario? So in this case, we are using artificial intelligence, but not the direct generative AI. We are using retrieval augmented components. That is, it will work based on the data we give it to retrieve response based on the data that we input. And that data is our integrated brochure and syllabus system. Okay, so the problem statements, prospective students, they struggle with identifying suitable program, and some because of lack of academic advisors that can guide them through. And also that lack of conversational intelligence, you just go to they want something, you can go to the interface. That is more reason why people are using ChatGPT, because of the conversational flow that system provides. So the proposed solution, this solution tackles that challenge of using AI conversational assistants and recommendation system. And unlike the traditional system, this approach provides that personalized course recommendation that matches with the student program. It boosts that retention, more like a direct chat. Now I did a fast review of some related works here. People that have done something similar, and these are two closest ones. The first one is Adepoju et al. In 2021. It did something similar, but it is not a conversational flow, and the limitation is majorly based on the fact that limited personalization, it is just generic. And the other one, it's actually conversational recommender, but it has limitation in the resource management. It's the code start problem. Okay, now I move to my motivation. The motivation behind this is most previous study reveals that course recommendation system, they lack personalization. They just give it out the way they are, and they are ineffective for new and first-time users. I want to reference Dr. Temitope. I guess he made mention of notes. I think he mentioned a platform where you upload your PDF and you can query that system to give you response. Yeah, when he was explaining review of literature, it's more like that, but in a more in technical terms, there's more abstraction. The technical part is left for the system. You just do your normal chat and you get your response. The aim and objective. The aim is to build that intelligent conversational system that will assist these prospective students in discovering the suitable university program based on their interests and career aspiration. And the one big problem that this is solving is you do not have to know the right prompts. You just flow naturally. So the objective to extract and structure information from the IBAS document. So it is not using the generic LLM something from, information from the chatbot. It is retrieving information based on the IBAS document that we have imputed. So another objective is to build that searchable admission knowledge database. All right, so because of our time, I moved to the architecture of this design. So the methodology in the data source is directly from the JAMB Procure. So I will want to add that the JAMB manages all tertiary institutions, but the scope of this system is just focused on the university system, just for complicity's sake. So there's Polytechnic, College of Education, Monotechnic, and other, certificate offering institution. But I am focusing on university. So the data preparation, the document is in PDF format. So it is not very easy to manipulate. A lot was done during the data preparation, the pre-processing, and all of that. So the model selection, I made use of BART large MNIA to perform zero-shot classification and intent collection to know the intent of the conversation. So the chatbot design and flow. I use Streamlit, is a library, Python library that provide the user interface. So that was what I used from my chatbots, and we evaluated the this performance evaluation. And also after the conversation, I shared a screenshot at the end of the slide. After each conversation, there is the option of downloading each interaction. So that could be used to build better system, like to make this system better in the future. So the data collection, like I mentioned, from the IBAS system, the BART large MNIA is a transformer-based model trained on the natural language intents to classify the student inputs and allow them to match different user interests to the right course. So the transformer model is a lightweight model that turns that text into vector embedding, that language that the system understands. Sorry, please kindly confirm if I am audible, please.
Yes, you have. We can hear you. Continue.
All right.
But you
right,
have
thank
like
you.
2 minutes left.
2
You should be
minutes,
rounding
that's
up.
fine. Okay. All right. So okay, I'm done with that. So this is just my use case to simplify how the structure of the program. The user enters the interest directly to the chatbots. The chatbot gets the recommendations, you view it. If you're not satisfied, you input other details. And at the end of the day, you can save that recommendation or export it out. So this is the screenshot of how the chatbot interface is. I'll just do a fast reading of what is it. The user just entered, I'm interested in anything that involves calculation. So the response is, it seems you're interested in mathematics. We would like to see the UTM requirements. So all of this output is based on the input, the IBAS data from JAMB. So it's not giving any generic response like GPT or other AI will give. It's retrieval augmented related. So because of my time, contribution to knowledge, number one is provide that scalable conversational problem-solving methodology, and also it adds to body of knowledge. At the end of these chatbots, you can see download conversation. So this will help to build a better system in the nearest future. I thank you very much for your time.
Yeah, thank you for the
These
wonderful
are the
presentation.
reference.
So welcome questions, suggestions, contributions on the presentation. Any question for Mr. Kabir?
I have one.
Okay.
Proceed.
Thank you for the presentation. So, during your explanation, you made mention of zero shot. Can you elaborate further?
Please come again.
You said it allows zero shot prompting. So, can you elaborate further on that?
I'm sorry, I'm not clear. I can't hear you.
He said you mentioned
okay.
zero shot. Can you elaborate on zero shot related to
Okay.
your proposed project?
Okay. I'm not very sure if I get that, but let me see. maybe I can make reference from my slide and get what
So in
is.
impromptu language, they will say a 0 shot, 1 shot, or 2 shot prompt. I think you made mention that
Oh,
in your
maybe
chatbot, 0
it's
shot
using
prompt.
that to describe the prompt, the lengthiness of the prompt, the input to the
Okay,
AI.
you said 0 shot, right?
Yeah.
Okay. I get you now. Okay, so that 0 shot is in a bid not to be generic, it is a built-in algorithm. So instead of just shooting around, it is narrowed down. So the input is students' interest text. It's, I don't know how to rank it. Like the okay, just like someone mentioned, just so that we will not, just to narrow it down, to narrow our response down. It's a 0 shot, it's a built-in Python model. Did
Thank
I
you. Is that
respond?
okay, Mr. Abu Huraira?
Yes, yeah. I
Okay.
mean,
Thank you,
okay.
Mr. Kabir. Any other contribution, questions, or suggestions? Okay. We have just one presenter left, but the person is not here. Abdulatif Okwemi Bakari. I don't know if. Okay, wait. I'm trying to find the person. Kindly fill the feedback forms for the presenters, please. You may not feel for yourself, but feel for others. I mean, the presenters should not feel for themselves. Okay. I'm trying to find the next and the last presenter, but I can't meet. Which is, I think this, no, no, okay.
Hello, can you hear me all?
Yes, I can. We can hear you.
Then I have a question for Mr. Mahdi.
Mr. Mahdi Abu Huraira is here.
Yeah, yeah, I have a question on your presentation. Mr. Abu Huraira, can you hear me?
Sorry, can you repeat?
Yeah, can you hear me now?
Yes, I can hear you.
So I have a question for you, like, how do you see like the feasibility or accuracy of applying your system to maybe real world, maybe large scale models?
Large scale model, I would say not yet. The research is still not yet there. Especially if we say, for example, in real world, you will need a decision to be made, say, for example, in 200 milliseconds. If we take, for example, autonomous vehicles, say Tesla Drive, it reads an image, it gives it model, and then the model interprets, say, for example, turn right. So we need to feed that into a pipeline that will perform a formal verification of if that image actually should translate to turn right. I mean, there is alpha crown algorithm that but we are not still not yet there, yeah. Because it will take at least maybe 300 seconds before a large model like that will evaluate the mathematical distance verification. So we are still not yet there.
All right, thank you for your response.
The only important part I see is, for example, certification. So with the large adoption of AI now, regulatory bodies like government would like to, for example, certify you that your model is safe for it to be deployed. But in that case, they can actually use that to certify you.
Thank you. We can't find the last presenter yet. Actually, it's supposed to be the first, but now we're almost done and he's not even here. We sent an email, so I'm just trying to check if there will be a response.
Okay, yeah, maybe we can give him
Yeah,
some
we can
time.
continue with the conversation.
Yeah.
Till I'm sure there's. I think no response from him.
Oh, okay, maybe he didn't join the
Yes, maybe. Dr. Temitope is here, right? Dr. Temitope? I think he left. Okay, he left as well. No response from him.
Oh, I guess maybe he had
Yes.
some other business, so he did not join.
Yes, maybe he's engaged or someone. Okay, I will check with the. Let me check with the response.
Is Mr. Ademi still here? I think Ademi.
Israel. Ademi Israel.
Yeah, can you hear me, Mr. Ademi?
Yeah, I can hear you.
So I have a question for you. Among the mathematical gaps that you have discussed about.
Okay.
Yeah, so which among do you think like is the most reliable that can change maybe or can help in changing the autonomous decision making in practice?
Yeah, please, can you come again with the question?
Yeah, among the models that you have discussed, the mathematical gaps. Sorry.
Okay.
Yeah, so which do you think is more reliable, like in help making like autonomous decision making in real application in practice?
Let me just say, when it comes to the mathematical principle is the foundation, right? It's the theoretical foundation of it. Without it, if the mathematical gaps is being, if there is a space between, like if it is not working perfectly well, if all the mathematical functions are not working perfectly well, it's going to affect the decision making. It's just like a foundation. It's just like a foundation. It does not affect the engineering part, but it will definitely affect the model part. So if the mathematical, if the before deploying, if it is well proved and well connected, is going to help the AI developers too. It's going to help the AI developers. Let me just say it's just like foundation.
All right, thank you.
Yeah.
Any comments so far? Have you filled the feedback forms? Please fill the feedback forms for our presenters.
All right, sir. All right, sir.
Mr. Kabir Suleiman, is he here? Kabir, I think he's gone. Okay. Miss Anna,
Sir, I can
do
hear
you
you,
have
sir.
any, I mean, your, what's it called? The two AI you presented, they were used for, I mean, ruminant animals, right?
Sir?
Your AIs that you presented on, they were meant for ruminant animals. Big animals. I think I saw some cartoons. Can you hear me? Hello? Can you hear me?
Hello.
Yeah. Okay. Do you have alternatives for other group of animals, maybe like the poultry, the birds, and some other animals?
For now is ruminant, sir. For now is ruminant because it's very easy to discover diseases in poultry because from
Okay.
their sounds, from the way they behave, from their feathers, you would have noticed that something is wrong with this bird. But for large ruminants, at times it's difficult to know something is wrong with them internally.
Okay.
Yes, sir.
You are more of the health aspects of the animal. Does it take care of the normal routine, like the feeding and other things like that, animal care,
Maybe we have
other
to
than
use
health?
robots.
What?
So for that, we have to use robots for that, like for
Robot.
daily routine. Yes, sir.
Okay. Okay.
Yes, sir.
Yeah. Thank you.
Yes, sir.
Okay. We'll end the room at the parallel session at 5:45. We'll join the one of the other rooms to converge for the rest of the program. But I want to be sure of the room we are to join very soon. And I'm also checking on the last presenter. But since there's nothing from him, and I don't think we received his presentation. I think maybe we should close this room, then we can join the main room. It's almost time. Have we filled the feedback forms? Please respond.
Yes, sir.
Okay, thank you. I mean, for all others, like the other 4 presenters, at least, since we have 5 in total.
Okay, yes.
Thank you. So presenters can join the main room. Okay. You can leave this parallel room. You can join the main room to continue the rest of the program. Thank you.